Python programming language has over 60 built-in functions to help you code more efficiently. In this video, we will discuss the function memoryview. Hi Python enthusiasts. In this video, we're diving into the memoryview function, a lesser-known but incredibly useful tool for working with memory-efficient data structures. By the end of this video, you'll understand what memoryview does, when to use it, and how to leverage it for better performance in Python. Let's get started. What is memoryview? It's a Python built-in function that provides a memory-efficient view of binary data without creating a copy. Here's the syntax. Memoryview with an object, where the object is a binary object that supports the buffer protocol, such as bytes, byte array, or other objects implementing this protocol. The result is a memoryview object that allows you to manipulate the data efficiently. Why use memoryview? It's a tool for working with large binary data without duplicating memory. Key concepts include: memoryview works with objects that support the buffer protocol, like bytes, byte array, and array.array. You can access and modify slices of binary data without creating a copy. It's ideal for applications where performance and memory usage are critical. You'd use memoryview when working with large binary data and need to avoid copying it. When you're accessing or modifying specific parts of binary data efficiently, and when you're interfacing with low-level data structures like file buffers or network streams. Let's start with a simple example of creating a memoryview object from a byte array. Here, memoryview creates a view of the byte array, allowing direct access to its memory. One of the key features of memoryview is the ability to access and modify data directly. In this example, modifying the memoryview directly changes the underlying byte array. You can slice a memoryview to work with subsets of the data without creating a new object. Here, the slice creates a view of the substring world without copying the data. Memoryview also works with other binary data types like array.array. In this example, memoryview creates a view of the integer array, enabling the efficient access to its elements. You can easily convert a memoryview back into bytes if needed. The toBytes function here converts the memoryview back into a bytes object without modifying the original data. Here are some important points about memoryview. It's ideal for performance-critical applications, where avoiding memory duplication is key. It only works with objects that support the buffer protocol like byte array and array.array. Use slicing and direct access for efficient manipulation of binary data. And that's the memoryview function. To recap, it creates a memory-efficient view of binary data. It's perfect for accessing or modifying data without copying. Use it with objects like bytes, byte array, and array.array for performance-critical tasks. Thanks for watching. If you found this video helpful, don't forget to like, share, and subscribe for more Python tips. Happy coding!